Voice-first AI means voice is the primary way you interact with the model. You talk, it talks back, it calls tools, things change on screen. In some of my projects, there is no text box at all. I learned this through 3 projects. Yarnsmith, a voice-first game where an AI game master narrates a role-playing adventure with an educational twist. Gym Coach, a voice-powered workout companion that talks you through exercises and logs your sets. And Canvas Chat, my visual interface for LLM conversations where I added voice on top. Each project surprised me, and the lessons converged on a single pattern. Voice plus tools on a web interface equals something genuinely powerful. Lesson 1. Docs and reference examples are non-negotiable. It is tempting to vibe code a voice app, spin up the real-time API, talk to the model, assume it works. It rarely does. Voice AI is so new that the leading coding models hallucinate the details. They invent parameters that do not exist. They use outdated SDK methods. They confidently describe behavior that changed 3 versions ago. The pattern that worked for me is this. Get the official documentation. Build one working reference example. Point your coding agent at both. Once I had a single end-to-end example where the voice pipeline actually functioned, that was enough for every project after. One working reference does magical wonders. The agents stop guessing and start following. Lesson 2. Build APIs first, then layer on tool calls. The breakthrough came when I structured the application around tool calls. Here is the pattern. Expose all the functionality of your app through API endpoints, then register those endpoints as tools the voice agent can call. The agent speaks, decides to take an action, calls the tool, and the action happens on the web interface. An API gives you flexibility that direct integration never will. You can have the agent call endpoints during a voice session. You can simulate the same interaction with curl. To debug, you can write tests against the same endpoints. The API is the contract, and everything else builds on top of it. Lesson 3. Transcripts are your lifeline. When you build a text-based agent, everything is visible. The user types something, the agent responds. You can read the full conversation. When you build a voice agent, most of the interaction is invisible. Audio goes in, audio comes out, and if something goes wrong, you have nothing to look at. This is where debugging hell starts. The fix is simple but essential. Always have a transcript. Every spoken word from the user, every response from the agent, every tool call and its result, all of it should appear as text on the web interface in real time. Without a transcript, you are flying blind. Lesson 4. Log every tool call with timestamps. A transcript of spoken words is the minimum. Voice agents introduce a problem that text agents do not have. Latency. Audio processing, network round trips, model inference, tool execution, each step adds delay. When the agent takes 3 seconds to respond, you need to know where those 3 seconds went. Every entry in your transcript needs a timestamp. Not just the spoken words, but every tool call. When it was initiated, when it completed, what arguments were passed, what was returned. I guarantee you will hit latency problems. When you do, the timing information in your transcript is the only way to diagnose where the delay lives. Lesson 5. Centralize voice operations into one component. Good logging tells you what went wrong. Clean architecture determines whether you can fix it. Here's a lesson I learned the hard way with Gym Coach. The symptom was maddening. The user would say, "Sounds good," and the coach would call a tool to save the workout plan. Then, silence. The coach stops talking. The transcript showed the tool call completed, but the voice agent never generated its next response. Gemini was waiting for a function response that never came. Debugging this was hell, because voice handling was scattered across 4 components. Each had its own assumptions about what should happen next. The root cause was the guards themselves. I had built behavioral guards to prevent bad behavior. When a guard fired, it blocked the tool call and discarded the response. But Gemini was waiting for that response. No response meant no next turn. No next turn meant silence. The fix was architectural. Over multiple iterations, all voice operations collapsed into a single component. The key change replaced blocking with description. When a guard fires now, it still sends a function response, but the response says blocked, plan already saved, instead of going silent. Gemini reads that and self-corrects on the next turn. The coach never stops talking. Lesson 6. Voice-controlled UI is genuinely magical. There is something viscerally magical about speaking to your computer and watching it respond. You say, "Log my set," and the UI updates. You say, "Show me the next exercise," and the screen changes. It is like science fiction. That experience relies on a design principle that is easy to miss. The action needs to be visceral and expose. When the agent takes a tool call, the user should see the result on screen immediately. Every tool call should produce a visible change. The user needs to feel that their voice caused something to happen. The pattern I have converged on, voice plus tools on a web interface, feels powerful but immature. Documentation keeps the models honest. API-first architecture keeps the system testable. Transcripts with timestamps keep the debugging tractable. Centralized voice operations keep the codebase maintainable. I am not yet sure where voice-first AI is heading, but the building experience has been the most fun I have had with software in a while. When you speak to a computer and it responds, you feel like you are living in the future. The trick is making sure that future also has good logging.